So we are starting chapter 8, which we are going to be estimating with confidence. So that means we're going to have some confidence intervals going on, and that's where we're going to start in 8.1. And then we're going to estimate a population proportion and a population mean with those confidence intervals. So in 8.1, we're going to interpret a confidence level, interpret a confidence interval in context, describe how a confidence interval gives a range of plausible values for the parameter, describe the inference conditions necessary to construct confidence intervals, and explain practical issues that can affect the interpretation of a confidence interval. Okay, so just kind of an introduction. Our goal in many statistical settings is to use a sample statistic to estimate a population parameter. So we learned in chapter 4, if we randomly selected the sample, we should be able to generalize to the population. And then if we did an SRS within that sample, then we can have cause and effect. All right, so in chapter 7, we learned that different samples yield different results for our estimate. Statistical inference uses the language of probability to express the strength of our conclusions by taking chance variation due to random selection or random assignment into account. Now in this chapter, we're going to learn one method of statistical inference, confidence intervals. So we may estimate the value of a parameter from a sample statistic. As we do so, we'll learn not only how to construct a confidence interval, but also how to report probabilities that would describe what would happen if we used the inference method many, many times. We're actually going to skip this part. All right, so confidence intervals. If you had to give one number to estimate an unknown population parameter, what would it be? Well, if you were estimating the mean, you'd probably use X bar. And if you were estimating the population proportion, you would use P hat. In both cases, you would be providing a point estimate of the parameter of interest. So a point estimator is a statistic that provides an estimate of a population parameter. The value of that statistic from a sample is called a point estimate. It's kind of like your best guess. Okay, so we also learned in chapter 7 that an ideal point estimator will have no bias and low variability. All right, so let's look at this first problem. In each of the following settings, determine the point estimator you would use and calculate the value of the point estimate. So in A, quality control inspectors want to estimate the mean lifetime mu of the AA batteries produced in an hour at a factory. They select a random sample of 30 batteries during each hour of production and then drain them under conditions that mimic normal use. Here are the lifetime in hours of the batteries from one such sample. So what would you use here if you wanted to have the point estimator, and what would that point estimate be? Okay, so I would use X bar for my point estimator. And X bar, if you want to go put those into your list and find what the mean would be, I got 16.7. So we would use that sample mean for the estimator of the population mean. All right, let's look at B. What proportion P of U.S. high school students smoke? The 2007 Youth Risk Behavioral Survey questioned a random sample of 14,041 students in grades 9 to 12. Of these, 2,808 said they had smoked cigarettes at least one day in the past month. So let's think about that. Well, they kind of gave it away when they told us even a proportion. So we're going to use P hat, okay, for that sample proportion for the estimator of the population proportion. And that's going to be 2,808 out of 14,041, which is about 0.2. C, the quality control inspectors in Part A want to investigate the variability in battery lifetimes by estimating the population variance, sigma squared. Okay, so we could find sigma of x bar here. And again, put that into your list. You probably already have it in there. And see what you get out for the sample standard deviation here. And I got 0.71. So we could use the sample standard deviation for an estimator of population variance. And you could even square that to get an even more accurate. Which I think is about 0.5. Okay. So for the sample variance, we could take the sample standard deviation and square it. All right, so the idea of a confidence interval, and we're not gonna look at the mystery mean, but it's basically you're going to like choose that point estimator and then see how close you are to what's actually going on. Let me get to it. Okay, I think I'm almost there. So you can look at that if you want. I know I kind of went over that fast, but if you'd like to go back and look over it, feel free to look over that mystery mean. But a confidence interval here is we're going to have that estimate plus or minus the margin of error. Okay. So the margin of error is going to tell us how close to the estimate, how close the estimate tends to be to the unknown parameter. And then, so that's the confidence interval. We have a confidence level, which is C, which gives the overall success rate of the method for calculating the confidence interval. So if you want to kind of say that, you could say C%, and C% of all possible samples of the same method, that's really important, would yield an interval that captured the true parameter value. And this is really important to know. So AP is going to ask this over and over and over. And I actually asked this on the final last semester, and students still didn't do very well on knowing the difference between a confidence interval and a confidence level. So you really have to get that difference down. So the confidence interval is the interval that you're going to be taking here, and but the confidence level is like, so if you're 95% confident, you could say 95% of all possible samples, this method would yield an interval that and we're actually going to have a little bit of a discussion about this as well. Okay, so here we go. Confidence interval, margin of error, confidence level. We really want to know all three of these. Okay, so the confidence interval has two parts. It's an interval calculated from the data, which you're going to have the estimate plus or minus the margin of error. And the margin of error tells us how close the estimate tends to be to the unknown parameter, with lots of sampling. And the confidence level is the overall success rate. So basically, in C% of all possible samples, the method would yield an interval that captures the true to see once we do an example. Now, when we do these examples, if they're not given, the most common confidence level is going to be 95%. So that's the most common if it's not given. So we can do, usually we want to do 90% or higher for our confidence, but the most common to choose is 95%. Okay, just a little joke for you. Taking a look at tomorrow's weather, the high temperature will be between 40 below zero and 200 above. And Garfield said, this guy's never wrong. Well, of course not. He provided a huge margin of error for us. Okay, if you can go to these websites, they're really, really good. Let me just click on one for you. But play around with it. It will really help you see what's going on. Loading. So this one was, let me look back. Whoops. Sorry, Grant. I just went and talked to Grant. I had to go find him. Ah! Where did it go? Resume slideshow. All right, so launch the confidence interval applet. Okay. Oh, golly. Confidence interval applet. Now let's find it. Oh, now it's blank, of course. Oh! Are you guys like just wanting to yell at me right now? You're like, Mr. Rose, just do this. Okay, sorry. Where were we? We're here. Applet. Now watch it be blank again. The confidence interval applet, right? Okay. Applets. And confidence interval. This is just a really great website if you ever want to look over any of them. All right, so let's just look here for a little bit. So you can pick the confidence level that you would like. And like we said, 95% is usually the most popular. And right now I have a sample of 50 SRSs, and the dot marks the sample mean, which is the center of the interval. And so let's just hit to go. Okay, so here you can see the dot showing up, which is the sample mean. And you can see when it actually takes on the true parameter value here. Okay, so that's the population parameter, and here this would be our sample mean going on with our SRS. So if we did that 50 times, we could see how many times the confidence interval actually contained that that population parameter. So you can see, this one did not, and this one did not out of 50. Okay, so go around, go look at those, do what I've kind of said here to change some things around and see what you notice. Hopefully you saw that when you changed around the confidence level, that sometimes the interval got shorter or longer, and that's really important to see what was going on. Also, if you made a higher confidence and you increase that, like it's getting wider, it's kind of like the Garfield joke of saying, hey, if I go like from negative infinity to infinity, I'm always going to be right. Ha ha, right? But that's that margin of error. When you have a really huge a margin of error going on, when you have a really big confidence interval, you can't be as accurate. So if you want to be more and more accurate, then you're going to have a bigger confidence interval going on. So it kind of plays into role like that. Okay. So the confidence level is the overall capture rate. If the method is used many, many, many times, starting with the population, imagine taking many, many SRSs, and the sample mean will vary from sample to sample. But when we use this method to do the estimate plus or minus the margin of error to get an interval, we're going to see things that looked like this. Excuse me, that's what we just did. Okay. So what we can say is 95% of these intervals capture the unknown population parameter, which in this case was a mean. All right, so the confidence level. Highlight this. Write this down. Big, 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 big. Ready? Confidence level. To say that we are 95% confident is basically to say 95% of all possible samples of a given size from this population will result in an interval that captures the unknown parameter. And you are doing the same process over and over. So possible samples of the given sample size using the same methods, however you want to state that, but make sure it's very defined here. So 95% of all possible samples using the same method from the same population will capture the true population parameter. Whereas the confidence interval, you're going to say we are 95% confident in this case. We are 95% confident that the interval from whatever this was, blank to blank, captures the actual value of the population parameter. And make sure you put that in context of the problem. Okay, so in context. Always, always, always in context. Okay? Same thing here. In context. Make sure you're always putting stuff in context. All right. Lots and lots of talking. So the confidence level does not tell us the chance that a particular confidence interval captures the population parameter. Okay? Instead, it gives us a set of plausible values for the parameter. And we interpret confidence levels and confidence intervals in much the same way, whether we are estimating a population mean, proportion, or some other parameter. All right, so what's the probability that our 95% confidence interval captures the parameter? Is it 95%? No, okay, it is not 95%. We have a 95% chance of getting a sample mean that's within 2 standard deviations if you did that other one, okay? So once we have chosen from the sample, you can kind of look down at the end. When you construct a confidence interval here, okay, so if you wanted to do that mean thing again from the beginning, you could. But if you want to construct a confidence interval right here, the probability that it captures the population is either it captures it or it doesn't. So 1 if it captures it, 0 if it doesn't. That's all. Okay, so don't confuse that with the whole 95%. All right, let's do an example. Do you use Twitter? In late 2009, do you guys want to know? I have never used Twitter still. I know, I'm so old-fashioned. Okay, anyway, I've never tweeted. All right, in late 2009, the Pew Internet and American Life Project asked a random sample of 2,253 US adults, do you ever use Twitter or another service to share, I do other service, to share updates about yourself or to see updates about others? Of the sample, 19% said yes. According to the Pew, the resulting 95% confidence interval is 0.167 to 0.213. Interpret the confidence interval and the confidence level. Let's see how you do. All right, so confidence interval. We are you looking back at your notes here? 95% in this case. confident the true population proportion of tweeters, is that how you would say it? Proportion of people who tweet or use other whatever updates lies within the interval 0.167 to 0.213. Okay? Now, the confidence level in 95% of all samples taken in a similar method will capture we'll have an interval, will contain within the interval the true or the population proportion, I can't spell, proportion of people who tweet. All right. And here it's even a little bit more specific. A little bit better answer. All right, exam tip. On a given problem, you may be asked to interpret the confidence interval, the confidence level, or both, and you have to know the difference. All right? So even if we're going to use this interval over and over and over in homework, I could throw out the confidence level just like that on you, and you have to know it. All right. So, how much does the fat content of brand X hot dogs vary? To find out, researchers measured the fat content in grams of a random sample of 10 brand X hot dogs. A 95% confidence interval for the population standard deviation is 2.84 to 7.55. Interpret the confidence interval. Interpret the confidence level. True or false, the interval from 2.84 to 7.55 has a 95% chance of containing the actual population standard deviation. Justify your answer. Ready, set, go. Let's see how you do. All right. First one. Confidence interval. We are 95% confident that the interval from 2.84 to 7.55 grams captures the true standard deviation of the fat content of brand X hot dogs. Number two, and 95% of all possible samples of 10 brand X hot dogs taken in the same way. Okay, make sure you kind of include that. The resulting confidence interval would capture the true standard deviation. So taken by the same method, taken in the same way. Okay, and the last one, false. The probability is either 0 or 1. That's what we just went over a little bit ago. So constructing a confidence interval. Why settle for 95% confidence when estimating a parameter? The price we pay for greater confidence is a wider interval. Okay. So when you want to become more and more confident, you're going to get a wider and wider interval. So this may be a 90%. This could be 95%. Think about if you were 100% sure, you'd have to go from negative infinity to infinity, which would be this huge, huge interval. Okay, this leads to a more general formula for confidence intervals. So the margin of error is actually our critical value times the standard deviation of the statistic. So this right here is going to be your margin of error. So you still have that parameter, okay, or sorry, that statistic, plus or minus the critical value times the standard deviation of the statistic. Okay, so you have the statistic is that point estimator. And I'll let you read through these if you'd like to. And that's kind of what we talked about. Okay. The margin of error gets smaller when the confidence level decreases or the sample size increases. So that's both important to know. And why would it get smaller when your sample size increases? So it's going to get smaller because remember the standard deviation when you have the n in that denominator, okay? You're going to get a smaller number than if you had a smaller n. All right, before calculating a confidence interval for the means or proportions, there are 3 important conditions you should always check. Imagine that, conditions. Random, normal, and independent. So random is that it's coming from a good random sample. Normal, if you have means, it has to be greater than or equal to 30. And for proportions, n times p has to be greater than or equal to 10. And n times 1 minus p has to be greater than or equal to 10. Well, we have seen that. Independent, you have to have the 10% condition met. So all of this we have seen before. So those are just conditions that we're still going to check. So let's look at this example. Many teens have posted profiles on sites such as Facebook and MySpace. A sample survey asked random samples of teens with online profiles if they included false information in their profiles. Who would do such a thing? Of 170 younger teens ages 12 to 14 polled, 117 said yes. Of older teens ages 15 to 17 polled, 152 said yes. All right, a 95% confidence interval for the difference in the population proportions is 0.12 to 0.297. Interpret the confidence interval and the confidence level. Let's see how you do. I will let you check. Make sure you got those. All right. The admissions director from Big City University found that the interval from 107.8 to 116.2 is a 95% confidence interval for the mean IQ score of all freshmen. Comment on whether or not each of the following explanations is correct. A. There is a 95% there is a 95% probability that the interval contains mu. Hopefully you're yelling false, false, false. There's either a 100% or a 0%. Okay, it contains it or it doesn't. B, there's a 95% chance that the interval contains X bar. Okay, false, X bar is what we're going to do, plus or minus the margin of error. That's our estimator here. Okay. So of course the interval is going to contain it. That's like 100%. All right, this interval was constructed using a method that produces intervals that capture the true mean in 95% of all samples. True. Okay. And D, 95% of all possible samples will contain. the interval. That's going to be false. Samples don't contain intervals. And E, the probability that the interval captures mu is either 0 or 1, but we don't know which. That is true. So in summary for 8.1, we learned about point estimators and a point estimate, confidence intervals, margin of errors, plus or minus from the estimate, the confidence level, the margin of error, the conditions to check. So we will be starting 8.2 next. I'll see you then.